So this is really about why we have architectures and what you need to think about when you are building systems that actually fit into those architectures and that lead to the architectures. I'm going to talk a little bit more about the MPLS architecture in particular, but I think this is kind of a general thing. So, another friend of mine, and I'm not going to name him, he said, I always wonder, and that's a quotation, I always wonder why we only can do one thing at a time, and compared it to a buffalo herd. So, looking at the buffalo herd and the characteristics, there is only one idea, and if it's a buffalo herd, it's probably getting somewhere else. There is only one joint direction. Everyone is running in the same direction. It's almost unstoppable, at least until the energy runs out. And once the stampede has started, no new input is accepted at all. So thinking about this, this is probably not bad. Not entirely bad, at least. This would be if I were a project manager, this is what I wanted to have. I tell people, go that direction, and they go that direction, do what I told them until they are done. The problem I would have is that if I needed to give the new directive, that wouldn't work. But I see the analogy of the buffalo herd as not entirely bad. The problem here is that the guy that actually spends most energy to get things done is the guy that actually will get most astray, most lost, while everyone else changes their mind or doing something else, stampeding in another direction. He is still doing what he set out to do at the start of the stampede. So, what I'm going to touch here is actually there are a number of changes to technology architectures that is not part of the stampede and probably should have effect on the stampede. So, we see that almost everything changes. And I'm going to take a look at how we view and perceive changes. First, there's one picture here and I have another picture here, so let's see what happens. So, evolving. So if we see that we have year 2015 now, we came here in some way. And I think there are basically two views on this. One is the pessimistic view, and the other one is the optimistic. So the pessimistic view starts with there were a golden age somewhere, some time ago, and since that, everything has gone downhill. The optimistic view is the other. There were a dark age some time ago. I don't know when, but there were. And then everything has been improving since then. I don't think those views are entirely correct, but I think there are some degree of truth in both. This is a quote, "The future ain't what it used to be, and what's more, it never was." You can tell me if you know who said it. Some people view changes as a pendulum. So first we do this, and then we do that, and then we do this again. But that's not, here this pendulum thing breaks down because we never go back and do exactly what we did before. So I don't think the pendulum theory is a good one. This is one of my favorites. I don't know how explanatory it is, but it has penguins. So this is the temperature scale where ice is melting, where water is boiling, and one end of the scale you have a lot of ice. It's so cold that even penguin freezes. And then you get above zero, and you have the penguins happy swimming around in the water. And then when things get warmer, you get steam. And yes, I know cloud is not a steam, so take the cloud away. But if you see penguins in this climate, then you are seeing ghosts. So there is a change that is kind of a physical thing. You go with small changes through the temperature increase, and the aggregate of water in this case are changing. You start with ice, you have water, and then you go to steam. Another view of looking at all the thing almost the same way is say that someone comes up with a bright idea. Most of the time the candles goes out and nothing happens. But sometimes there is a small change and something start happening, and you can build on a number of small changes. So you can, in the MPLS case, for example, take the small label stack and things like that, and then you go on and make small changes until you suddenly have a big change. And this is, in the MPLS case, probably the first time when MPLS VPNs come about. And then you can start building new types of VPNs, you can start building new capabilities into MPLS, and suddenly you have a new set of changes that are rather big. And I think we see one of them just now, things like SDN data centers, things like that. And then you go on, and the shape of MPLS as such has changed a bit. And instead of being a star or a geometrical figure, it kind of comes out as a box. But the thing is that the changes are small and incremental. Some of those incremental changes pushes you kind of over the edge or into something new. So we have a document, IETF document, the MPLS architecture, and we've been talking about kind of rationalize that a bit to look at what we have in, what are the architectural principles. Obviously we have one. We have a data and control plane separation. Data and control plane are basically independent, or actually the data plane is independent and the control plane is there to create control of that data plane. We have several independent control planes. There are LDP, there are RSVPT, BGP. You can have a centralized controller like the SDN. You can have things like everything goes into an NMS. We have a very small MPLS header. We call it a label, and the label can be stacked. The label has, and I say this, and sometimes I get misunderstood. I say that the label has a link local significance. Actually, it has a significance for the node that are assigning the label and communicating it to some other node. There is a small exception to this. We have 16 special purpose labels. Actually, today we have another 256. But of the base labels, there are still only 16. So we also have some guiding principles, and the first one here is one that has been around from the start, was actually where we started to discuss MPLS, whatever it was called at that time, 95, summer of 95, I think. So that is coexistence with IP, and I rather like to think about this as actually an IP toolbox. So things you can do to IP network to improve the workings of IP networks. We have IP-based control planes, and that is still almost true. We have reuse of IP protocols. The most pregnant example is the RSVP-T. Was there long before MPLS and is still there and is integrated part of MPLS. And we also made sure that the protocols we make, protocols we specify, are extendable. So that's one side of it. And then there are things that has been turned down. Some of them returns with some frequency, 5-6 years. One of those things that have returned now and then is global labels. So people want to say the labels from 100 to 4,000 does have the same meaning in the entire network. We have over and over agreed on this is not a good idea because it will actually deplete the number of labels that we have available. We have also said that we don't want to have any other encoding in the label than actually taking it from what you use to make the forwarding decision. Likewise, we have declined having special encodings of bits in the label value. So you can imagine every label that actually starts with the first bit, the highest bit set has special meaning, but we are not going there, and we will not go there. And then people have tried to make semantics for two labels. So you pop one label, do something to the one beneath it, and then you put the first label, top label back on again. Again, that's not supported in any MPLS hardware today, and I don't think it will be supported. Big labels. People say we need more labels. Well, maybe, but the way to go is not to go to big labels. And we declined using, and here is a typo. It's not a class of service any longer. We actually changed the name to traffic class, so it should say TC and TTL bits. We declined special semantics for those other than what actually was specified from the beginning. And then we have bottom of stack bits, where it has been tried to set it more than once in the stack, but we ran into problems on that. So that is some of the ideas around the MPLS architecture on a rather high level. So what is the architecture good for? Well, first of all, it's good for avoiding what I talked about as the dead-end mistakes. For example, we don't want to do pop, swap, push operations in such a way that they violate the current architecture. However, the architecture is not that anything that is really set in stone. It's barely a bit hard to change. but it will change, and it does change. So if you need many more labels, the way to go is not to go to 40 or 80 or 120-bit labels. The way to go is actually to do context labels. So you assign a label to change the context, and then you have a new set of 1 million labels that you can work with. The architecture is also there to support new applications on top of MPLS. What we see today is, for example, virtualization. I think there will be one talk about virtualization. Andy, will you talk about virtualization? No? Okay, so there won't be any talk about virtualization. However, there will be at least one talk about superscaling. Lu Yan will talk about hierarchical SDNs later in the week. And then supporting things like SDN. I need to tell this. I made a presentation a couple of days ago on where SDH, you remember the plain old SDH from the 80s, was part of the presentation. So I told someone about my presentation, and he reacted. He's like 22 years old, and he reacted very quickly. No, you mean SDN. So, no, I meant SDH, but here I actually mean SDN. So if you're in the room, now I'm talking about SDN. So MPLS architecture is there to support, for example, applications like data center and SDN. As I said, the architecture is changing, but it's changing more slowly than the technology as such. I'm confused because I see two different pictures. So there are a number of views about what MPLS is. I think that most of them has a point. No one really explain everything, so you need to be able to move around between the different types of explanations. So let's see. I'm going to say one thing first. Glasses. So people that have different views of what MPLS is very often behave as if they have the truth. And as if they have specific colored glasses on. So the drawback having a specific color on your glasses is that you don't see some things. So let's see, you have the 1 to 7 different colors. So let's put on the blue glasses. Makes the 3 disappear. So the person with the blue glasses can't see the 3. And this is an experiment. You can do it at the party if you want. You have an instruction for people to do things. And then you have 3 different types of glasses, and you hand them out, and then you hand out the instruction and ask people to do what's on the paper. The key here is that you color the instruction the same as the glasses. So people will kind of start arguing about what they should be doing. And they can't agree. There's no way they can't agree because they don't see the same thing. So you need to step back, look upon what people think MPLS is, and then make use of it in the situation where it's relevant. So there are 2 things: layer network and network layer. They are very, very similar, but they are quite a bit different. So a layer network is something that comes out of ITU-T G800, G805. So, and this is transport. So you have a point where you can feed things into your network, and it comes out as the same like some other point. And this is kind of explains something, but not everything. The other one is the ISO reference model. Well, ISO reference model is old. It's still there. For some purposes, it still have relevance. But people say MPLS is layer 2.5. Well, it's not layer 2.5 in the ISO reference model because there is no layer 2.5. They say MPLS is layer 2 in the ISO model. So the characteristic for a layer 2 technology is that they have a common media access control. Well, everyone failed so far to show the media access control for MPLS. And then we say that it's layer 3. Well, the common part of the ISO model is that it has a common network addressing, and MPLS doesn't have that network addressing. It's in IP. It's not in the MPLS part. So clearly, MPLS is something different, and I don't know exactly what. So I've been saying that MPLS is a toolbox. And I guess that helps to explain something, but not everything. So there are, yeah, it works. So there are a number of tools like explicit route, network optimization, stable path, and the typo in my slide. It should be point-to-point and point-to-multipoint transport. And then there are a lot of OEM and management improvements over the last 4, 5, 6 years. So the toolbox is there, it helps you to do things, and if you want to look at it as a toolbox to improve the workings of IP networks, that is pretty close to the truth. About a year ago, I started to talk about MPLS and kind of surrounding technologies as a jigsaw. It is important that things fit together, and I still think it is. Though the jigsaw does not actually explain how things fit together, just that they do. So what we started with in MPLS was that it actually was married to IP. And it actually developed quite a bit, all the way up to where we started to do layer 2 and layer 3 VPNs. And that was what actually broke I shouldn't say broke, I should say that was actually took MPLS out to a huge market and where every operator started to use it. What we see now is that we have the next step going on. We have SDN coming around. It's not replacing VPN, but it's adding new requirements on MPLS. One slide. So those requirements, and so when we're developing a technology, I can go here. This is the planet system. So like a planet system, technologies that we have around MPLS, like data center, service chaining, VPNs, virtual network, SDN, all of them fit together. And it's really important that we don't make changes in one of the technology to the MPLS architecture that actually is hindering the other technologies to go ahead. So we need to make sure that the architectural evolution is taken on carefully and actually coordinating in such a way that we really have an MPLS technology like in 3 or 4 years. What happened? Nothing? So the summary of this is that we have an MPLS architecture. It's actually a treasure trove. Something we can use to do a lot of things, but we need to make sure that it actually stays that powerful tools and take care of the treasures that we do about all other treasures. So I think I'm done.
Thank you, Loa. So one of the key takeaway is really the power of an MPLS is the label stack. That makes it scale. It's not flat. Questions from audience? Yakov. Okay. Mike? Mike?
I can hear you, but I don't know whether everyone else can.
Actually, two questions. One small question in your list of the basic ideas in MPLS. You didn't mention the controversy over global label versus local meaning. I'm wondering if you purposely left that out because of the modern developments, like things like segment routing, etc. And the other question is, no, I didn't see it there. Maybe I missed it.
I think I did.
I didn't see it, but okay, maybe I missed it. The other question is, follow on to what Lujan's just said. In the age of SDN, where everything is sort of being managed by the omniscient controller, do we really need most of the work of MPLS, all the control plane, all that goes away? All we need is one label on top to differentiate a packet, right?
Jakob, I have a story, and you can think about it a bit, and we can go back and discuss it somewhere. So I worked for Ericsson from 1984 up to 98, and then I took a tour around a couple of companies, and then I was back to Ericsson around 2007, something like that. When I was at Ericsson the first time, I was part of developing the LAPD protocol for ISDN. And that was kind of a hot topic at that time. The thing here is that when I was back, second week I was back at Ericsson in 2001, there was someone internally Ericsson called me to ask questions about LAPD. So I don't think that everything will go away. There will be a shift in importance, a shift in how much things are used and why things are used. But I think that things won't go away, and every damn thing I've been involved in inventing or evolving will come back and bite me sometime. So, yeah, I agree with you. We probably don't need, but it still will be there. Okay.
Thanks, Loa.
Thank you.